Good morning, everyone. Welcome back. I hope you had an amazing fall break. And I'm ready to get back into, when I say one slide, I'm talking about this is one slide. All of the slides for the whole week are posted in the Monday folder in Schoology. You're going to need to return back to that Monday folder each day to do another slide. Now I will post a video showing you how to do these problems, and I just post one day at a time. So this is Monday's video, and we're going to go over these 5 problems. Tomorrow I'll post another video showing you how to solve the problems on slide number 17. Okay, so just kind of giving you a refresher, making sure everybody remembers our routine. You have a couple of choices. If you want to upload handwritten work, you can do that. On the Google Slides, you can just upload a photo of what you've written. Or you could also show your work on the slides using the tools in Google Slides. That's up to you. Math routine, we're going to start with our bell ringer. Now remember, you need to do one of these slides each day. Okay, so let's go ahead and get started. Remember some vocabulary words for us here. When we're talking about multiplication, factor times factor equals, what vocabulary word should go here? What's the word that means the answer to our multiplication problem? That's right, it's our product. Now when we're talking about division, we need to remember that our dividend is the number that we are splitting up or sharing. We divide our dividend by our divisor. That's the number that tells us how many equal groups we have or how many people are sharing something, for example. Those two things equal the answer, and what do we call the answer to a division problem? That's right, it's our quotient. Now, if you see a division problem written like this, then we will organize the numbers this way. Dividend goes underneath the house symbol. I call it a house symbol. I know that there is a more technical math term for it. One of my students last year looked it up for me. I can't remember what it is. So 36 in this case divided by our divisor, which is 9, gives us a quotient of 4, or we could also say 36 divided into 4 equal groups gives us a quotient of 9. Dividend divided by divisor equals our quotient. Okay, here we go with our measurement problem. I'm sure you remember our wonderful little rhyme that I taught you, combined with my amazing artistic skills. This is clearly a fly, in case you couldn't tell. If we're changing fly to horse, nay. Okay, so I have a toddler and we're teaching him animal sounds right now, so sorry. That's just like my state of mind right now. Let's see, fly to horse. Divide, of course, meaning if you have a smaller unit of measurement, for example, if you're converting inches to feet, you would divide in order to calculate that. Inches to feet. Maybe you want to convert centimeters to meters. That's another example of a smaller unit of measurement converting to a larger one. If you're talking about liquids, you might be converting, that's wrong. You might be converting milliliters, which is a very small unit of measurement, milliliters to liters. A liter is like a bottle of soda, big bottle of soda. Think of it that way. On the other hand, if you're taking a larger unit of measurement and converting it to a smaller unit of measurement, then you would multiply. So in that case, we would say horse to fly multiply. This is a fly, obviously. Bzz, bzz, bzz. So we need to think about what we're doing here. We're converting 9 feet to some number of inches. 9 feet to some number of inches. A foot, I can visualize a ruler that I might use to measure how tall I've gotten or measure how long my shelf is where I need to put some books. And on that ruler, I can see markings showing me that there are 12 inches in that foot. So we're changing a larger unit of measurement, feet, to a smaller unit of measurement, inches. So that tells me I'm going to take my 9 feet. I need some more space. I can't work like this. Okay. I'm going to take my 9 feet, multiply it by 12 inches in each foot. Now 9 times 10 gives me 90, and 9 times 2 is 18. So that tells me that 9 times 12 is 108 inches. Okay, so that was horse to fly multiply. Then I have my 72 inches divided by 12 inches in each foot. Okay, so let me think about what math facts I know. I know that 12 times 5 is 60, which tells me that 12 times 6 is going to be 72. So 72 divided by 12 equals 6 feet. Okay, here we go with a volume question. Now, in order to solve this, I'm going to kind of split this figure into 2 different shapes, because the formula for calculating volume is length times width times height, and it's going to be easier for me to do length times width times height for these 2 separate shapes and then just add those 2 volumes together. So just a refresher, because I know we've been on break, volume is a calculation of the inside space of a 3-dimensional shape. Now, a 3-dimensional shape is one that has 3 dimensions: length, width, and height. And so the unit of measurement that we're using for these figures is cubic units, and it doesn't specify in more detail than that. Like sometimes you'll see cubic feet, cubic yards, cubic inches, cubic centimeters if it's something really small. But in this case, we're kind of just using generic cubic units. Okay, so I'm going to calculate, let's see, length of the green shape is 2. Width, I can see 1, 2, 3, 4 cubes going front to back. So I can infer that there must also be 4 cubes. You know, I can see the front here of this cube, but I can't see the back. And then height, I can count 1, 2, 3. So this figure that I've shaded in green has a volume of 2 by 4 by 3. 2 times 4 gives me 8, times 3 gives me 24 cubic units. And then I'm going to add to that the volume of my blue shape. So let's see, I have a length of 2. Length and width are kind of interchangeable, so you can call this length or width. 2 by 1, 2, 3, 4, going backwards, and then just a height of 1. Okay, so 2 times 4 gives me 8, times 1 more, of course, is just 8. That's the identity property of multiplication. And 24 plus 8 gives me, let's see, 24 plus 6 gives me 30. Plus 2 more gives me 32 cubic units. When you're writing your units for volume, you can write it U to the third power, and this is kind of like a code that means cubic units. All right, here we go with some geometry. We're going to make some observations about this polygon, starting, of course, with the fact that it is a polygon. It has 3 straight sides, 3 angles. It's a closed shape, so that makes it a polygon. Now, let's see. Knowing that it's a polygon, I can look at these angles, and do you think that these angles are acute, obtuse, or right angles? To me, they look like they're acute. I'm gonna go ahead and say there are 3 acute angles. And one way that you can test it, this is easier to do if you don't have, I wonder. This is a little easier to do in person, but what I would do is draw a shape that has a square corner or a right angle. This is a right angle because it's exactly 90 degrees. And then if we were in person, I would say you kind of match up this 90-degree angle with the one you're testing. And can you see it is definitely bigger? If I make this one come in front, it'll be easier to see. Okay, so now it's a little easier to see. You can see that this angle here is a lot smaller than my red 90-degree angles. Okay, so now what I'm gonna do, I want to be able to talk about specific angles. And the way I need to be able to communicate that is by labeling my sides of my polygon, A, B, and C. Each side has its own name. And then when I want to talk about one specific angle, I'm going to use this symbol, which is like a little picture of an angle. And then if I want to describe this angle here that I'm shading in red, I'm going to name it angle AC because it's the angle that's created by lines A and C. So I can say angle AC is acute. Okay, and then if I want to specifically talk about this angle here that I'm shading in green, I would call that angle I would call that angle CB, angle CB, because it's the angle created by lines C and B. That one is almost 90 degrees, but it is actually acute. It's just ever so slightly smaller than 90 degrees. Okay, and then this one is also 90 degrees, yellow angle, which I'm going to name angle AB. So that's how you name your angles and your sides. Okay, so this is an acute triangle because all 3 angles are acute angles. Okay, when I am looking at your work, I want to see math vocabulary. I want to see the words acute angles. Don't tell me they are little angles. I want to see you starting to label your sides and label your angles. And I want to see evidence that you've watched my videos in your work. Okay guys, home stretch. Here we go with our line plot. I'm going to draw my x-axis, which is the horizontal side-to-side line. And I'm going to put my intervals on here. Let's see here. Looks like my smallest value is 43. So I'm going to start with 40. And then my highest value looks like it's 59. So I'll go up to 60. 50 in the middle. Midpoint. Okay, now remember the trick I taught you. If you want to make 5 equal spaces in something, draw 4 lines. If you want to make 10 equal spaces, make 9 lines. So I would never take off points for you guys having sloppy lines, but I just want to make it easier for you if I can. Since these we need to have 10 equal spaces, I start by making my midpoint. And then on each side of the midpoint, I draw 4 lines, and that creates 5 equal spaces on each side of the midpoint. 55. Okay, so now I can go ahead and start marking my pieces of data. You can't get credit for this if you don't label your intervals. Some of you are drawing lines but not labeling the intervals on the lines, and so then I don't know what these X's represent because I don't know if they are at 40 or 100 or 200 or what. So please make sure that you label those. 51, 43, 2 of those, 49, 43, 51, 53, 59, and 43 again. Okay, so remember when I taught you guys the word that means our most frequently occurring piece of data? That's our mode. Our range is our smallest piece of data to our highest. Our smallest piece of data is 43, not 40. Sometimes people get confused. I don't have any data above my 40, so I don't include that in my range. 43 to 59, that's my range. And then I have one outlier, which is like a piece of surprising data that seems like it doesn't really belong with the rest, and that's my 59.